The directions are to find the absolute extrema. So I'm going to go ahead and check with you guys what you got for your derivative. Oh my goodness. This is the one we kind of went over in class, but we didn't go over it for very long. It was tricky because of, hey, the unit circle. Oh my goodness, everything comes together. So, question. You had to start off with the derivative, right? Because what's our steps? Ooh, let's review our forever card number 19. Yeah? What are the steps to finding absolute extrema? Find the critical numbers first. I mean, technically check the domain. Technically we have to check the domain. For instance, secant 1 over cosine. For us, just considering who secant is. Cosine can't equal 0, so x wouldn't be able to equal any pi over 2 plus pi n. So 3 pi over 2, 5 pi over 2, all of those would be DNEs, all of those would be vertical asymptotes. But are there any pi over 2s in between? No, so we're okay. So then after we think about our domain, then we go to what Trisha was saying is critical numbers. We have to take our derivative first, which hopefully is straight out of your forever code. What do we do with the derivative for critical numbers? What equal to 0? Each one? The function? Good. But actually, you're supposed to pitchfork it, aren't you? But some of you are like, no, there's no pitchfork because there's no top or bottom. Isn't there a bottom? Maybe some of your lives would have been easier if you had thought about a pitchfork and thought about secant as 1 over and tangent as 1 over. You would end up with the zeros of sine. In my head, I always come back to this. 0 pi and 2 pi are all zeros of sine. So we have from the top 0 and pi and 2 pi, etc. The only ones that are in between, though, too big, all we have is 0. And then when cosine equals 0, we already talked about that. That'd be negative pi over 2, positive pi over 2, 3 pi over 2, etc. in both directions. But that's not in the interval. Well, none of them are. So what's the only critical number to worry about? Technically, these were vertical asymptotes of the beginning, so we wouldn't have actually called them critical numbers anyway. They were domain restrictions. But at this point, what's next in our forever card? Consider the domain, find the critical numbers in the interval, and then what? Oh, come on. Notes open. You're supposed to have them close anyway. Go ahead and open them on up. Section 3.1, forever card number 19. The steps for finding absolute extrema, or how to find absolute extrema, or how to analyze absolute extrema. We considered the domain. We looked at critical numbers. Now what? Make a table, right? Did you guys put a little table next to that? Make a table. So we have x and we have g of x. The table is neat. Well, it needs to have what points, what specific x values in it, guys. Negative pi over 6 because we're supposed to put in the endpoints, right? Pi over 3, and then what's supposed to go in between the endpoints? Any valid, which is just 0. Then all we have to do is plug and chug. What's secant of negative pi over 6? Unit circle. Maybe you should tutor some pre-cal kids and remind yourself how to do it. Negative pi over 6 is a little baby 1/6. Cosine is root 3 over 2. So secant will be 2 over root 3. Cosine's positive, so secant's positive. All students take calculus. 0. Cosine is 1, and 1 over 1 is 1. And then pi over 3, that's up here. Pi over 3, cosine is 1/2, and flip that in 2. This is going to end up being the biggest. Why? Well, hold on. Let's think about this guy for a second. 2 root 3. You might not know who he is, but isn't he going to be in between 2 root 4 and 2 root 1? Wait a minute. Inequalities go the other way, don't they? How'd I do that? Well, I know that that's going to be 1 and that's going to be 2, so this guy's somewhere in between 1 or 2. So is he the lowest or the highest? Wow. I only thought we were half dead. Are we all dead? Do I get some check pulsing going on, like coming around and feeling your neck? What's going on? What's going on? Is this true? Okay, so what does that mean? This is a decimal in between. What's 2 over root 4? 1. And what's this? 2. So this is something in between 1 and 2. So if he's in between 1 and 2, is he the lowest? This function goes. No, because what's lower? Is he the highest? No, because how does the function go? I'm annoying myself talking like that. Come on, let's wake up, yeah? Stop, give high fives, don't spill any coffee, turn it on 3 times. No, just pause. Stand up. Stand up. Yours started off. We're just going to do a big long line all around the room. Walk around the room, yours. This way. This way, yours. This way. Form a line. Follow the leader. Just join wherever they go. Join, join, join. March, clap, give high fives as you go. Say hi, say good morning. Let me open the door. As you're walking, does it make sense that this is going to be the location of the absolute min and this is going to be the location of the absolute max? Okay, so problem number 36 is answered. As you get back to your seat, write down anything that you want. I'm going to freeze the screen for about 2 seconds and go find 67. I think more of us need 67. I'm freezing the screen. If you want anything else, number 67, let's go there. Check them out, guys. You were supposed to write down the directions. Why was 67 weird?
Because it had a formula.
Yeah. Yeah, right? Like batteries and amperes? What? Amps? Oh, amps. That maybe is something you've heard of before. Anyway, that was a nasty formula. Impossible for you to deal with unless it was related rates. But they didn't talk about P changing, V changing, I changing, R changing with respect to time. Wasn't related rates. Huh. How many batteries are they actually talking about in this problem? This is the formula for all different types of batteries. Power output of a battery. But how many batteries are they talking about? 1 battery. They're analyzing one specific battery, and the one specific battery has one specific voltage and one specific resistance, aka their constants. What can I do with constants? For this one battery, always, always. Oh! So I can say that P is equal to 12I minus 0.5R I squared. Who likes 0.5? Nobody. Let's make it 1/2, okay? Is this something I can take a derivative of now? Wait, why would we take a derivative? What word in this entire problem makes us think derivative? Max. How do we find a max, an absolute max? Critical numbers. Is this something I can take a derivative of? Sure, I only have 2 variables, so it's going to be d di of both sides. That's awkward. He's y, he's x. I have 12 minus 1i. What's my critical number? Oh, sorry. I said equal to 0. Yeah, 12. Yikes. Good thing you guys are here. How do I find an absolute? No, because you add the I or you subtract the 12 and divide by 9. Yeah, just think also 12 minus 12, not 12 plus 12. That's the first answer. Well, wait a minute. No, it's not. We have to find the max. Hold on. Assume that a 15 amp fuse bounds the output of the interval 0 to 15. I can't just box the 12 and say automatically it's the max, right? Haven't we been having to test it the whole time? So what do we test that critical number with? Yeah, and what are the endpoints? You see it? So we can make our chart of here are the I's and then here's the P's. So if it's bounded by 0 and 15, we figure out that 12 is the critical number. We don't even need to know anything about batteries or amps or ohms or electromotive forces. all you do is plug in 0 and say, okay, sweet, plug in 0, that's 0. Maybe that makes sense. There's no current, there's no power. Anyway, plugging in 12. It's going to end up being, can I do anything with that? Not really. It's going to be 144 minus 144 divided by 2. What's that, 72? Is that okay? Then we have to plug in 15. 12 15ths, or 12 times 15. Minus 1/2 of 225. 12 times 15, I see that. 10 times 15 is 150. 150 and more 15s. Oh my goodness, is my sound on? 150 and 30 is 180, right? 150 and 30 is 180. Yeah. What's 180 minus that 1/2 of 225? Will that be 112.5? Mental mathers, we doing okay? That'd be 70, 60, 67.5. Who wins? Ha. Oh. Okay. Well, that wins. That's going to be my max. But then it goes on to say, could the power output be increased by replacing the 15 amp fuse with a 20 amp fuse? So what if instead of going up to 15, we said, ha-ha, he can go up to 20? Well, what would that change in this whole situation? Yeah, instead of testing at 15, where would we test instead? At 20. But does anybody realize that it goes up to here and goes down to here? It's just going to keep on going down. If you needed to, you could go ahead and multiply 12 times 20, which would be, what, 240? Minus 20 squared is 400. 400 divided by 2 is 200. But does that help anything? No. So it's not going to make any difference putting in a higher amp fuse. If anything, you're just wasting money. Being like, yay, it's more powerful. No, it's not. It's not going to be able to go any higher. May as well just stop at a 12 amp fuse, or maybe go a little bit higher for 2 minutes. Anyway, long story short, I know it was confusing, but do you see how absolute extrema is all they needed to do? They just made the problem look really weird, and it all came back to one battery. This isn't moving or changing. One battery has a constant voltage and a constant resistance, which let us make the formula that we were going to use as far as finding the max. David, does that answer the question okay for you? Okay. It was nasty, but hopefully it doesn't look impossible now. All right, cool kids. Mean value theorem, Rolle's theorem. And if we do well today, maybe we can finally get up to the ornery pumpkin farmer. What? There's an ornery pumpkin farmer. Theoretically that we were supposed to hit before Halloween, but as you can tell, we're a little bit behind. All right. But in like a, hey, big guy, like in a affectionate way, not like a literally you're big. All right, you guys should have gotten this down yesterday. We are going to build forever number 20 out of the mean value theorem, out of MVT. So let me zoom in on him. I will zoom back out to look at Rolle's in just a second again. Rolle's is the specific one that was found first. Mean value theorem is the general one, aka the more useful one. So for instance, if I was talking about test corrections that I was working hard on yesterday and last night, trying to get you points back on the Chapter 2A test. If I was to say, example student, not using any names, someone went from a 72 to an 81. Was that a specific case of someone's grade changing? Yeah. Does that help you know how your score changed? Maybe. Couldn't you do 81 minus 72 is 9 points? I got 9 points too. Great. I went from a 99 to a 108. No, you didn't. Well, I'm not meaning, never mind. Anyway, that wouldn't have happened. That wouldn't have happened. Why? Because test corrections got half points back of the ones that you were able to show me you could do correct. Does that make sense? So that 72 to an 81, maybe that was the maximum number of points possible? No, they could have gotten 14 points back if they had done everything perfectly. Oh, bummer. They must have not done everything perfectly. Isn't it more useful to know the general than a specific most of the time? Same thing here. Roll is a very specific example, and it's super useful sometimes to know, but MVT is the more general one. So I want you guys to label mean value theorem as MVT. Let me move the forever number 20 off to the side. Mean value theorem, MVT. Hey, what other abbreviations or theorems that have been abbreviated have we memorized yet this year? IVT, and then we saw on forever 19, even though it's kind of a note at the end, EVT, and now we have MVT. IVT, in between, intermediate. EVT, extreme value, extrema, mins, maxes. MVT, mean value theorem. Ooh, it's not very nice. No reaction? Anyway, mean value theorem. Let f be a function that satisfies the following two hypotheses. F is continuous on the closed interval. If you want to make a little note to yourself, because you're like, that means nothing in my head. It needs to be continuous from closed endpoint to closed endpoint. Yesterday we saw when there was a hole. It was the very first one you guys did all together in the back of your homework spiral. Remember there was a hole? And when there was a hole, we had no minimum? We can't have holes. Hence, f has to be continuous from endpoint to endpoint, if you want to put it that way. F has to be continuous from endpoint to endpoint. However, number 2 isn't talking about the function existing, it's talking about the derivative existing. So f has to be differentiable on the open interval, aka, if you want to put a little note, I won't make you put it on a forever quiz, but just as far as clarification, no DNEs of the derivative. That's what differentiable means, right? The derivative has to exist, able to be derived. So the first f is continuous from endpoint to endpoint. The second one, f is differentiable everywhere in between. No DNEs of f prime, and maybe we should just say in between. And that describes the open and closed interval. From endpoint to endpoint has to be at the endpoints, but this one in between says I don't care about what's going on at A or at B. I just care that there are no sharp points or vertical tangent lines in between. If these two conditions are true, then I can say there is some sort of x equals c in A to B such that f prime of c is equal to f of b minus f of a all over b minus a. Wait, we've seen both of these guys before. Isn't this a formula on the motion forever card that some of you didn't get written down the first time? The motion forever card, hopefully we've all found. Isn't this average rate? If this is average rate, then who's this guy? That's average rate or average slope. What's this guy? Yeah, instantaneous. Good, Rachel. Instantaneous rate. Average rate. Hold on. What's the mathematical term for average? Mean. Dun, 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 dun. It's not nice either. Dun. Okay. Mean value theorem. So average, if you want to, you can go ahead and write mean. Now hold on. This is the general one, not the specific one. The little note comes from down below. At some point in the closed interval, the instantaneous rate equals the average rate. The average rate, the mean value of the derivative. The mean value of. Okay, I'm not going to box it quite yet, because I still want us to put a quick little note about Rolle's theorem. I still want to put a quick note about Rolle's theorem. I'm going to go ahead and erase this just because I technically wrote it down below. So this is just labeling. At some point in the closed interval, the instantaneous rate will equal the average rate. Average, you might want to put mean in there as far as a way of remembering. But we need to make one more note, kind of like we did on the last forever card, to stop us or to keep us from having to make an entire EVT forever. For absolute extrema, EVT was written at the end of that card in that it said, if a function is continuous on a closed interval, there will be an absolute max and min by EVT. Oh, that was what EVT said. This one, if f of a and MVT applies. If f of a equals f of b and MVT applies. Well, okay, that's something extra. So MVT applies, all this is true, and there's an extra condition, f of a equals f of b. Guess what? Then f prime of c must equal, what's going to be f of b minus f of a if they're the exact same thing? Yeah. That's Rolle's. That's Rolle's. So if anyone says Rolle's theorem, you can go ahead and know what it is. It's just a special case of MVT where f of a equals f of b. So the mean value theorem, MVT, let f be a function that satisfies the two conditions. F must be continuous on the closed interval a to b, able to be derived, aka derivative existing on the open interval a to b. If those are true, then there must be some sort of x equals c within a to b, very similar to IVT, such that, now it changes. Not f of c equals k like IVT, but f prime of c. The derivative must equal f of b minus f of a all over b minus a. And by the way, if f of a equals f of b, that's going to be 0. Dun, 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 dun. That's our forever card. So this is forever number. Simplifying your life a little bit by putting two big ideas into one, but just like the AP guys would do, because guess what? AP guys never really name Rolle's theorem. They're like, nah, whatever. Yeah, he was important, but who cares? It's kind of sad, really, but that's all right. They always just say MVT. So we're going to do it like the AP guys would. Forever number 20, yeah? Try to make it look at least a little bit more put together. There we go. Hey guys, in some way, shape, or form, you're good at memorizing. You might not think you're good at memorizing. You might be like, man, I still don't know my derivative rules, but that might be a sign of laziness, or it might be a sign of you're not studying the way your brain needs. But either way, to make it to AP Calculus, you have to at least be able to somewhat memorize. Think back to biology. How did you memorize? Think back to vocab quizzes. How did you memorize? Think back to, I don't know, anywhere else, physiology. How did you memorize? Think back to last year in the trig formulas. How did you memorize? You have to memorize some things in calculus. They're called the forevers. Please don't just give up on me. We're only at forever 20. Some are easier. Some are harder. The harder ones, you got to dig in. Maybe rewrite. Literally write by hand on a whiteboard. I've had some kids just get a whiteboard out and they just write it over and over and over and over and over. It sticks for years to come. I've had some kids be like, I can memorize it the day before. And it sticks around for about a day. Awkward. And then they have to do it all over again. So figure out a way to memorize, all right? But MVT, let me show you Rolle's really quickly. Rolle's says f of a equals f of b. And the function is continuous, aka from closed circle to closed circle. Yeah, no jumps, no holes, no vertical asymptotes. And differentiable, aka only smooth turns. This one, not a smooth turn. That one actually fails MVT and Rolle's because it fails the whole differentiable step. This sharp point says, nope, not differentiable. But as long as there's a smooth turn, and f of a equals f of b, in order to get back to the endpoint, I'm going to somehow smooth turn. And when I smooth turn, the derivative must be 0, at least one place. That's what this is saying. And mean value theorem says, hey, we can tilt the whole thing. And tilting, oh, where's my tilting picture? Oh, there's my tilting picture. Here, let's steal this real quick. My tilting picture says, Mean value theorem graphically, you don't have to put this on the forever card. You really don't. It might help if you do, but you really don't. The tilting picture says, or mean value theorem says, we can tilt rolls, and f of a doesn't have to equal f of b. I don't care who this guy is, but as long as it's a guy who doesn't have any sharp points and any vertical tangent lines, it only turns in a smooth way and continuous from endpoint to endpoint, there must be at least one place where the tangent line will equal the instantaneous rate will equal, the tangent line will equal the average. So question goes, as you look at this, f on a closed interval, endpoint to endpoint, and differential smooth terms. Can you guys approximate for me, if this is negative, approximate a place where the tangent line would be the exact same slope as this guy? Maybe don't approximate where. Approximate how many times it will happen. Think about moving around the curve, and as you move, how many times will you have a slope that is parallel to the Remember, beginning of the year, tangent line is a pencil that curves, right? That skims. Come on, you see one right there, right? Okay, keep counting. How many do I have? Because couldn't I say there's one right around, oops, sorry, I didn't mean to have that. Struggle, man. There he is. Double struggle. Toil and trouble. That's not quite how it goes. Couldn't I say that there's one about there? Couldn't I say there's also one about here? Couldn't I say there's also one about here? And also one about here? Now these ones, the ones that I just made, I'm going to make a different color because they're not secant lines. They're not averages. They're instantaneouses. They're places where the derivative would equal the average. The original one was the average, just connecting the two endpoints, but all the rest would be instantaneous. Long story short, yeah, we could find C's. There are 4 of them. But the theorem says there's at least one. Is there at least one? Yeah, there's 4. Where the tangent line will be parallel to the secant line. In context, the instantaneous rate will be equal to the average rate. Mathematically speaking, f prime of c will equal f of b minus f of a all over b minus a. That's MBT using graphs. Now let's go ahead and just talk about using math. We're going to do examples of rolls and MBT, but remember, they're basically the same thing, but what's different with rolls? Look at the note. They're basically the same thing, but what's different with rolls? F of A also has to equal F of B. Okay, so both of these say determine whether the theorem applies, and if it applies, find the C's that are guaranteed. Find the C's in between A's to B's, where it actually happens. Because this one, guys, was super imprecise. I was like, meh, there-ish, 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 there-ish. The math lets us find it perfectly. Okay, the first one. The first one. Is this function continuous? Any domain problems? Holes, jumps, vertical asymptotes? Nah, it's a polynomial. Wait, polynomials always are continuous, and they have what kinds of turns? Always smooth. So guess what? I can already say, yeah, he's going to be continuous everywhere. Okay, so in that interval. Technically, if we're trying to learn the theorem, I'll go ahead and help a little bit. Just because we know how a polynomial works, he is continuous on the closed. He's continuous everywhere. And he's differentiable on the open. Well, he's differentiable everywhere. But I'm just saying the theorem applies. So far, check. And if those two are true, which they are, you don't even have to really state anything unless you want to say, oh, it's a polynomial, duh. Then we can say there exists an x equals c that we need to find within the open interval -1 to 3 such that, wait a minute, this is rolls. Something extra is supposed to be true, right? What's the extra piece that needs to be true? Yeah. and f of negative 1 equals f of 3. How could we test that? Plug it in, plug it in. So plugging in negative 1, isn't that going to make everything 0? Plugging in 3, that's going to make everything 0. Oh, hey. Rolls does apply. Now I can go ahead and say, all right. So now that all my conditions are met, I have the continuous, I have the differentiable, the continuity and the differentiability. I also know that f of a equals f of b. Now let's go into, okay. Micromarians, I should probably take out my comma. So that one's true, that one's true, that one's true. Then we can say there is an x within negative 1 to 3 such that f prime of c. Who is f prime of c? Equals 0. Well, I think I have to actually find it. So the derivative of f of x is going to end up equaling second d first plus first d second. Good thing we reviewed some of this yesterday. I used the product rule, but guys, did you also check my chain rule? Second d first derivative of x minus 3 is 1, plus first d second derivative of u squared is 2u times u prime. Please tell me you see the green trick. What do I mean by green trick? Homer's fact. Yeah, what's in common? X plus 1. So when I pull out an x plus 1, I get x plus 1 plus 2 times x minus 3. You might be like, I don't know how to do that one. Yes, you can. Yes, you can. Yes, you can. Because can't you just simplify that inside piece now? So if you guys are distributing and if you're combining like terms, what I see is a 2x minus 6 plus 1 would be a 3x minus 6 plus 1 would be a 3x minus 5. Anybody get there before me? X plus 1, 3x minus 5 equals 0 at x equals negative 1 and 5/3. Whew! So if that's the special x has a name, and the special x's name is C. Wait a minute. Are both of those my answers? Only which one? Only 5/3. C is equal to 5/3 because it needs to be, according to the theorem, in between. I'm not saying it's not true at negative 1. It's just not guaranteed by the theorem at negative 1. 5/3 is the only one guaranteed because we're looking for in-between values. We're not going to go through and do all of these. Let's just do one more. One more rules. Absolute value nobody likes, so let's do that one together, yeah? So what's the first thing that I had to do up here? What was I checking for? Continuity. Continuity, I asked myself, are there any domain problems or like piecewise functions not matching up? Any holes, vertical asymptotes, denominators equal to 0, square roots with a negative? Any problems? I have absolute value, right? I have absolute value. So you might be a little worried about the absolute value, but Nick just brought up something good. He said sharp point, and he's very, very, very right, but that's not a problem with continuity. What are sharp points a problem with? Differentiability. So guess what? He's fine as far as being continuous. If f is continuous from endpoint to endpoint, plug in 0, 1, 2, 3, 4, 5, 6, or any decimals, it's going to work. It's a number. So it is continuous on 0 to 6. I'm going to take out the if and say, even though. Why am I saying even though? Yeah. Even though f is continuous on 0 to 6, f is not differentiable. Can anybody tell me where? Where the sharp point is? Do you know absolute value is enough? Three. Just positive 3. Just positive 3. Because positive 3 is the separator for the piecewise function of the absolute value. If it's higher than 3, positive stays the same. If it's lower than 3, it's a negative flipping. 3 is that sharp point, that sharp turn. 3 is the 0 of the absolute value. Rolls. DNA, what? Does not apply. Rolls does not apply. You could also say rolls fails. Do you have to do anything? No, you're done. Oh, sweet. I'm going to like that homework problem, right? Dun, 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 dun. Now, what's different when we do MVT? Would have technically have had to also do f of a equals f of b. If you plug in 0, that's going to end up being 0. And if you plug in 6, it's going to end up being 0. If you didn't catch the sharp point, you would have been like, rolls of course applies, and you would have gone looking. It wouldn't have worked. You wouldn't have found it. It couldn't have possibly been true. Your math wouldn't have worked out, and so that would have also been a clue. But sometimes the math does work out, and you're like, oh, it does apply, but it never did. So just be careful. The sharp point was kind of hiding. We had to look at that. Another way of finding a sharp point is we could have technically taken the derivative to check it. Derivative of 3 is 0. Derivative of absolute value of u is absolute value of u over u times u prime. Question, does this derivative exist for every single value between 0 and 6? When x equals 3, the derivative does not exist, hence is not differentiable. So even though Nick saw the sharp point and said, I know what that graph looks like, no! He was right, but the math would have told us that also. This doesn't work at 3, and 3's in between, so no. Okay. MVT. Check out your forever card. Do we get to start the exact same way? It's differentiable. For MVT, do we need to do the extra f of a equals f of b part? No. So we're only doing 2 things. All right, guys. Well, he's a polynomial. So what would you say about him? Yeah. F is continuous. And not only continuous everywhere, but okay, fine, on the closed interval from endpoint to endpoint. How can I also say differentiable? Everywhere, but on the open interval. How do polynomials move? Smooth turns. A parabola, a cubic, a quartic, they're all smooth turns. Or you can derivative and say 3x squared plus 1 never doesn't exist. That's awkward, I'm sorry. Exists for all values of x, especially or particularly the ones in between -1 and 2. So MVT says, if that's true, yep, and if that's true, yep, then what are we able to say? Read me the card, then. Within f prime of c equals. Do you guys see how I didn't put in b or a, but I put in 2 and -1? You know why, right? Is that okay? Because for this example, my a and my b are -1 and 2. So now all I have to do is actually find it. Find what? Find the c's. Maybe there's 1, maybe there's more. How do I find it? I take my derivative, 3x squared plus 1. I said equal to, plugging in 2, that's 8, 10, 6. -1, -2, -6. Help me out, my mental mathers. And 2 minus -1 is 3. 6 and 6 is 12. 12 over 3 is 4. 4 minus 1 is 3. Divided by 3 is 1. X squared is equal to 1. Ugh, someone get there and make sure I'm right. I have a couple head nods. Do I box both and say, yay, C equals both? No. Who am I going to cross out? Because I'm only looking in between -1 to 2. So forget that guy. He's not guaranteed. He's a guy. He just isn't allowed to be included in the problem. Dun, 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 dun. Do we have the idea of MVT and rolls? Before we can ever apply it, we have to make sure the conditions are met. If f is continuous on a closed, if f is differentiable on an open, then f prime of c always equals f of b minus f of a all over b minus a. But if I have this extra special condition, f of a equals f of b, then this will end up being 0. So I can kind of skip a step. I can skip the plugging in step, or I could just use MVT every single time. And when I go to use this, if roles did apply, I'll just get a 0 and say, oh, hey, it was. Oh, hey, it was a rules. That's the idea of section 3.2. We do have another graph, but for sake of time, I don't know if I necessarily want to stress about that graph right now. Maybe we'll use it as a homework help tomorrow a little bit. But let's go ahead and really quickly write a quick note about tangent line versus secant line. I'm going to move this page. It's not a bad page. It's just not a super necessary page. Let's move it down here in like the homework help section. I'm going to have you guys totally attempt homework tonight, but I'm going to give grace if you're not able to finish the whole thing. What does that mean? Submit it even if you're not able to get all the way to the end, but show me a pretty good attempt. Does that make sense? Okay, so I can see where you get stuck. Like try a little bit, calc chat a little bit, but if you're like, I'm legit stuck, then stop. Tangent line, do we know this one? Yeah, what's a line? Equation of a line. Oh, we're in calculus. What are we always going to use for a line? The nice thing is, guys, that's just a line. It doesn't really matter whether it's a tangent or a secant. That's just a line. For a tangent line, we say, oh, okay. Y minus f of a equals, who's my m? F prime of a. For a secant line, you could technically use f of a or f of b. It doesn't really matter which point you use. They're both going to be on the line. But what's different is that you're going to use f of b minus f of a all over b minus a. For a secant line, you're using an average slope. For a tangent line, you're using a regular slope. And while we're at it, what are we going to do for something called a normal line? Does anybody know what the word normal means in physics? Perpendicular. So it's going to be y minus f of a equals negative 1 over f prime. Negative 1 over. It's like you're taking the opposite reciprocal. Oh, that's a thing in math. And with that, we're going to end with, we barely got there. Might not actually be able to solve it, but that's okay. Okay. I don't know why I said things 3 times in a row. You'll still be entertained by it. Someone with a good reading voice. Not me. Struggle. Who has a good reading voice and can read kind of fast? Ryan, go.
Calculus cops have set up their left graph out of the stretch of a suspected pumpkin farmer who uses the road daily to haul his pumpkins to market is suspected of chronic speeding well beyond the posted limit of 55 miles per hour. The calculus cops aim to finally ticket this unlawful transporter of seasonal gourds. The calculus cops set up 5 miles apart from each other, each parked prohibitively behind a piece of scenery. Cop A spots the farmer with his jalopy loaded down with would-be jack-o'-lanterns. As the farmer he's clocked it up.
Pause. Keep going.
Cop A could have joined the farmer wait. Calculus B. Cop B 5 miles down the road, whereby Cop A's timer. 4 minutes later, Cop B clocks the farmer cruising by at 55 miles per hour. He clearly sees the farmer with a giant grin that would make a jelly. After a quick calculation on his field issue TI 88 and a half calculator, he pulls out with his lights on to issue 80 tickets to the
Buzz. All by MVT. We'll see you tomorrow. Bye, guys. If only cops had calculators, we would all get tickets and had time to target individual people. Bye.